Hi, I am from Social Research Insights. In this videocast, I am going to show you how to interpret the regression output in LibreOffice Calc installed in Ubuntu 14.04. The mission of Social Research Insights is to promote open source software for data analytics for both academic and corporate needs. This is in fact the third videocast of my series of demonstrations on regression analysis through LibreOffice Calc. LibreOffice Calc is a wonderful spreadsheet application, an open source alternative to Excel, Microsoft Excel. It has all functions required for statistical analysis as well as mathematical computations and miscellaneous operations. And in this videocast I am going to show you how to interpret the output generated through regression analysis in LibreOffice Calc. In video number 1 I explained the simple linear regression and a function called linest to compute the estimates of the regression and also obtain the p-value in order to assess the significance of the estimates. So we'll be having beta naught hat and beta 1 hat, and these are the standard error for the beta naught hat and this is the standard error for the beta 1 hat, and we can compute the t statistic by computing the beta naught hat by its standard error, and in the same fashion we can also compute the t statistic for beta 1 hat. And through the functions available in LibreOffice Calc we can also compute the p-value for both of the t statistics for beta naught hat and beta 1 hat, and these p-values will help us to assess the significance of these estimates in order to come across the inference. And in this videocast I'm going to demonstrate I'm going to explain you the meaning for the measures that are computed through regression analysis in LibreOffice Calc. So when we execute the linest, the function which is available in LibreOffice Calc to do the regression analysis, we will tend to get some certain summary measures for regression analysis, and I also have a small image which will explain about the summary statistics that are computed through the regression analysis. And the summary statistics, there are some important measures here we need to discuss. I'm going to copy them and paste in a separate spreadsheet, space special, and disappear the formulas and appear the numbers. Okay. So now we are going to what are these values and how are we going to report these values in our research report, because we do the statistical analysis in order to use it for our research. So we should know the meaning for these values to make them a bit relevant for our research reporting. In my previous video I shown you how to make the summary out of these measures, and the summary goes like this straight away we can take it to the report. And now what are these values like and what's going to happen? We already know what is the beta naught hat and beta 1 hat, and coming to the standard error for the beta naught hat and beta 1 hat, this is just it helps us to standardize that particular estimate of the regression analysis. Say for example here the standard error for the beta naught hat is 0.13. so when we divide this beta naught hat with the standard error, as usually in any standard distributions, we have to divide the measure of the analysis with the respective standard error. For example, if we are going for the t distribution or t statistic, we have to divide the difference between the individual value to that of mean with the help of standard error, and the standard error in this case is going to be the standard deviation divided by square root of n. In the same fashion, if we want to make the t statistic from for the beta naught, we can simply divide the beta naught with the standard error of beta naught hat and that gives us the t statistic. So this is the culture in statistical analysis to divide the particular measure with its standard error in order to standardize that particular measure. Now beta naught is roughly t statistic. It is no more beta naught because we standardize that value and transforms that value into the t value. Now it is possible for us to go for the inference. So that is what precisely we did in our previous video. And now coming to the same action we can perform even for the beta 1. We can divide the beta 1 hat by its standard error, and it will give rise to the t distribution. This is what we call the statistical diagnosis for regression analysis. Beta 1 hat, and it will give us the t statistic, and based on the t statistic we can compute the p value, and the p value will be useful for us to make the inference. And now coming to this r square, as you can see in this image, the immediate value just below the standard error for the beta 1 hat is the r square. The r square is also known as the coefficient of determination, and which is going to be, the value of r square is going to be sum of squared residuals or error divided by the total sum of squares. So that will gives us the coefficient of determination. The other method of finding the coefficient of determination is also through the Calc-Pearson correlation coefficient. Given some Calc-Pearson correlation coefficient, we just have to square the value. But in regression, it might not be the case in all situations. So the straight method, or the right method to compute the coefficient of determination is through finding the ratio of the standard error to that of the total the sum of squares. Usually in regression analysis, the sum of squares always must be minimum, which means it should be approximately 0. So the purpose of the regression analysis is to minimize the sum of squares so that it reach to the value of 0. And any moment we find 0, it simply means that we have a better regression fit between the variables under study. Let it may be x comma y or y comma x. One must be the independent variable, the other must be the dependent variable. So now there are other couple of measures here we completed in through our previous videos, or the demonstrations. That is the significant test for the error, where we used a chi-square statistic to assess the error variable. See, here we compute the error variable and we got the sum of the squared error, and we used that value in order to compute the chi-square statistic, and after that we assessed that value with the help of the p-value that we have calculated through the chi-square distribution by using a function called chi-dist. And now we found that we don't have enough information through our sample to accept the alternative hypothesis that the values are significant. So the values are not significant, they are as expected, which means we have a good regression fit. Now how are we going to report those values? That is the question. But before going to that concept, let me finish my rest of the demonstration by explaining the other measures of regression analysis. And I finish explaining you the coefficient of determination, which I told you that we'll get it by computing a ratio of the squared and the sum of the squared error to that of the total error. So now here the sum of the squared error is also known as SS reg, which means regression error, the error which is explained by the regression model. And SST is SS reg plus SS residuals, the error, the variance which is explained by the error alone. So which means in case if we have a regression fit, and this is the beta naught hat, and this is the beta 1 hat, and plus x and plus error. So the sum of the squares SSE SSreg is the variance explained by the fit values or fitted values, and the SS residual is the variance explained by the error. So we have two different types of the measures to explain the error in the model, in the data, through the model. And now this is what we are going to do. So we just have to pick up the values. Here we have the sum of the square explained, I mean the variance explained by the regression model, and the variance explained by the residuals. The other name of the residual is the error. So now if you ask me what is R square, and the R square simply is going to be is equal to sum of the squared regression, or the sum of the squares for the regression divided by the total amount of regression, the total amount of variance in the model. So that's going to be 0.084, which is exactly the R square value we obtained through the linear estimation through the function called linest. So and there is other measure called F. So in this case, as we have the bivariate data, F might not be useful for us to assess the model, but in multivariate regression, the F statistic is very much important for us, and the F is obtained through the means sum of squared residuals divided by the mean the sum of the squares for the total model. We simply call it MSE divided by the F statistic is going to be MSC, the means squared error, divided by MST, the total error in the model, and the mean MSE is going to be SSreg divided by the degrees of freedom for regression divided by SS total and the degrees of freedom for the total data. So here the degrees of freedom for the regression is we have two parameters, 2 minus 1, which means 1, and the degrees of freedom for the total data is going to be n minus k. In this case we have the degrees of freedom for the regression model 1, and the degrees of freedom for the total data is going to be 20 minus 2, which means 8. It is there already in our model, 18 here. So that way we compute the F statistic that you can experiment yourself in your LibreOffice Calc, and I just leave that topic. So here actually indirectly what we are doing is the ratio of the mean squared error to that of the total error. This is the mean squared error and total error. The mean value of the sum of the squared error to that of the mean error of the total error. So that is what is the F statistic, and this value roughly needs to be 1. So anything above 1, it simply means that the regression error, the mean error of the regression, is more than the total error. So that is what is the meaning of F statistic. And we can also do a small significant test for F. See here I have the F statistic, and if I compute the p-value, if I want to compute the p-value, F dist the calculated F value, comma, and degrees of freedom 1, degrees of freedom 2. So that will give us the p-value, and here in this case the p-value happened to be greater than 0.05 at 5% confidence level. In significance level, I am going to reject the alternative hypothesis, and I have no objection to accept the null hypothesis that the parameters under study obtained through the study are as expected. They are not obtained unexpectedly. So we have a better regression model with us to explain the data under study. And finally we have this two measures that already explained you. This sum of the squared, the error explained by the regression model, the error explained by the error, I mean the residuals, and they are in fact the values which we must use in order to compute the F statistic, as I have described in my presentation. Like this, we have to use this the two different errors, sum of SS reg by SS total, in order to compute the F statistic. So these are what the measures. Even if we do the same analysis in Microsoft Excel, we are going to obtain the same values. So now we can just copy all these values and use it in our report. What I am going to do, I just make a provision for these values in my sheet. I'm going to write it as this is the T statistic, and here I have to copy the chi-square statistics, and together with the p-values for the and here I come and put the r square. Already have that in my r square and f, and I am going to keep the degrees of freedom for regression SS reg, so degrees of freedom for SS reg and degrees of freedom for total data. So degrees of freedom for SS reg is going to be k minus 1. In this case, the k minus 1 is going to be number of columns minus 1. So I'll get 1, and here is going to be count n, total number of cases, and cases minus number of parameters, that is 18. So now I can format the entire table so that it is useful for me to put it in the report. So what I'm going to do, I just make a little bit I'll just tweak my table a bit more and make the values quite relevant for my reporting. And I also make a graph here so that it will be useful for me to add visualization to my report. What I'm going to do, I just highlight my actual values and the fit values and also the error term, and insert a graph chart. So it will gives me a pop-up window where I can choose a line diagram with smooth type and press finish, so that I can have a wonderful graph, and I can also put a border for my graph. I should search through where is the border area. Somewhere I must have this the option border is okay. Let me see if I no, I'm not going to get it. Okay, anyway, it doesn't matter. Like, later we can see that where it is, but that as such that is not going to be very much important for us. somewhere I must have that option here to leave it. Well, anyway, we got this. If you observe the graph, the blue color, the line highlighted in blue color, it is actual values, and the line highlighted in red color, the fit values, and the line highlighted in yellow color, these are the error variable. So if you observe very clearly that the fit values are in the fit values and or the are in tune with the error term, and when we add the fit values with the error term, that's going to be the actual diagram. So you can just simply change these values and see what's going to happen to our graph. In case if you are interested to see how this graph is going to change for the different values, say for example, all these lines are in tune with each other. So we have that shows that our regression model is rather a best fit. In order to make it a worst fit, what should be the size of my y variable? Say here, let me change the values around right. I multiply with 100 so that I inflate the values, and let me see what's going to happen. 85. See, you see now there is a lot of change in the graph. See, the error is above the fit values, and the actual values are in tune with each other, but whereas the error raised above the fit values, whereas in the previous case the error was far below, and it was around 0, but now the error increased. So when we inflate the y values, the error also increases. And I go further. I do I'm sorry, I should see that it will take different shapes for different. So I multiply with 1000, and let me see what's going to happen. Round 1000, and let me see what's going to happen. I think the error should increase. Yes, now you see that the fit values and the actual values are roughly same, but whereas the error is increasing. You see the y-axis value, it's going it's increasing unimaginably, and the fit values as well as so the fit values and the actual values are related together. The size of the fit values pretty much depends on the size of the y variable, which means the dependent variable, and the error is independent. That is what you should observe. So let me go back and make my round and multiply with 10. We'll go back to our, and let's see what's going to happen. Now this time we have only one. We don't have the decimal number. You see, now they are slowly trying to converge with each other, and I still decrease round rand. I just take random value and take 2 digits. Let's see what's going to happen. This time my error reduces. You see, error reduces, and it is very near to 0. See, if the values are identical, you find that error is approximately equal to 0. If the values are not identical, then you find the error inflating, and the fit values and the actual values are roughly converging with each other. So that is what that is the advantage of adding visualization to the regression analysis. So what we have to do now is that you just can paste all these things and use them for reporting. First I am going to make the table 1, where I am going to put my analysis regression table, and there one important the feature in LibreOffice Calc is that you can just copy your values, and when you copy your values and paste it in the LibreOffice Word, you still can edit the values right staying in the LibreOffice Word. So I just format these values and copy this table, paste it here and anchor that, and you are going to have that table in. So if you double click anywhere in the table, you will be having the spreadsheet here. You can just edit the values. That is the advantage of using LibreOffice Calc together with LibreOffice Word. And now I'm going to use the other measures. So table 2, the summary measures of regression analysis in LibreOffice Calc. So what I do, I go to the other, here I have the summary measures for my copy and paste it here, and you can just report as it is, as I have explained in my demonstration in your report. And now let us go for the graph. Let us go for the graph. So copy, come back, paste it here and anchor that, so that you'll be having a meaningful graph for your analysis. I think I'm not able to push this into the same page, but it doesn't matter, you can let it change that. So now I have this. Okay, all the three tables at one place. Now your analysis is over. You can simply start talking about your analysis here. You can just say that the p-value for the beta naught is significant, p-value for the beta 1 hat is not significant, and the r value is not significant because we have the p-value here 0.21, so which is not significant, and r square is only I think 0.6% of the variance is explained by the regression fit, and the error is also not significant because the p-value for the chi-square statistic is 0.5, which is greater than 0.05, and at 5% significance level we are going to state that the error is not so dangerous in the regression model, and we are actually accepting the null hypothesis. All the measures of the regression fit is an ideal fit, and it is as expected. And you can also talk about the graph as I have explained in my demonstration, and you can make a beautiful paper in case if you have some original data collected through a study. Thank you.